This video is to help support GCSE students in understanding the electrolysis of copper to support them with the controlled assessment investigation. Okay, so the first thing you need to do is make sure that you know the piece of equipment that are going to be needed to carry out any electrolysis. So pause the video here and test yourself on what each of the boxes are going to say. Okay, so let's have a look. So number one is pointing to the cathode. The cathode is the electrode that is attached to the negative end of the terminal. So if we look up here at the top, we've got the negative side of the power pack or the batteries, and the negative electrode is attached to that. So that makes it the cathode. So over here, number two. This is the positive electrode. This is attached to the positive side of the power pack or the positive side of the batteries and is named the anode. So number three down at the bottom. This is the solution that the electrodes sit in, and it's known as the electrolyte. Okay. The next is what's going on inside the electrolyte. So which ions are being attracted to the cathode? Well, the cathode's negative, so it's going to be attracting the positive ions, and those are known as cations. Remember, pussy cat, and you've got positive cations, so positive cations. Okay, the ions then that are being attracted towards the positive electrode, these ions are going to have the opposite charge, so they're going to have the negative charge, and they are known as anions. So what actually happens at the electrodes? If we look at this section here, so let's look at the positive electrode first. What's happening here is that the anions, that are the negative ions, are being attracted to the positive electrode. They then give up their electrons. So here we can see that the ion is being split into an atom and an electron. So they give away that electron to the electrode. And so they become atoms and electrons. So that process, because it's the loss of electrons, remember oil rig, oxidation is loss of electrons. That process there is known as oxidation. That electron then travels up around this circuit, through the power pack and into this electrode here. And so that's what makes this electrode negative, the cathode. So here, the ions, the positive cations that we've got represented as M plus here, gain the electrons to become just the atoms of M in this case. So these positive cations that have been attracted to the cathode have gained an electron to become neutral atoms. And this process, because we're gaining electrons, is known as reduction. So from oil rig, oil, oxidation is loss of electrons happening at the anode. Rig, reduction is gain of electrons. So the ions are gaining electrons to form atoms. So let's put that specifically into what we've got going on in our investigation. So our electrodes are both going to be made from copper. So we've got a copper anode and a copper cathode. The electrolyte is going to be a solution of copper sulfate. So that means we've got copper ions and sulfate ions in the solution. So the copper ions are going to be attracted to the cathode because they're positively charged ions, and the cathode is a negative electrode. And the sulfate ions are going to be attracted to the anode. They're negatively charged, and so they're attracted to the positive anode. At the cathode, the normal electrolysis process happens. So the copper ions are going to this. I'm getting 2 electrons because we've got a 2+ charge, so to be able to cancel that 2+ charge there, they need to gain 2 negative electrons, and copper metal is formed. So you get a coating of copper metal around this electrode. So in effect, the cathode will grow. Unusually, at the positive electrode, the sulfate ion doesn't change. What happens instead is that the copper metal actually splits up into copper ions and electrons. Okay, so this actual electrode here is going to start dissolving or disintegrating. And so the copper ions will go into the solution to replenish the copper ions that have formed copper atoms on the cathode. And it also releases the electrons that need to go around the circuit into the negative electrode. We can show this in a different way as the copper metal solid here losing 2 electrons, so minus 2 electrons, to form the copper 2+ ions in the solution, so AQ there. That's releasing the 2 electrons that then go around the circuit and make the cathode negative, and they're the ones that join up with the copper at this side of the electrolysis cell. So overall, this is what's going to happen, is that the anode is going to disintegrate or dissolve. Any impurities that were on it will just drop to the bottom of the beaker, and the cathode will become greater, so it'll start gaining in mass and gaining copper atoms, so this one will grow. And this is a method that's used to purify copper. So if we've got copper in a relatively impure form, we can electrolyze it such that the impurities drop off. The copper obviously dissolves from this side, but then is made on this electrode here. Hope you found that useful. If you need any more support with this, obviously feel free to talk to either myself in school or any of the chemistry teachers.